All right, good morning, everyone. Welcome to Assessing Node.js Web Application Security. Am I clear? Cool. My name is Vince Marcovecchio. I'm a member of the BlackBerry Security Research Group, which I've been with for about 5 years now. We largely do internal pen testing and vulnerability assessments. My original training is in computer engineering, so I started on the dev side of things and kind of went on to the darker side of security, had more fun. My story starts because 3 years ago we had a dev team that approached our team and they told us they wrote a product in Node.js and they wanted us to do an assessment of it, and we kind of turned to each other, and none of us had ever worked with Node.js before and had no idea what we were doing. So this is kind of the story of what I've learned over the last 3 years, more or less. I'm coming at this from a white box assessment perspective, so we usually have source code when we assess apps. And what I'm going to be looking at is the sorts of gotchas that I look for in Node.js code. We'll start at the JavaScript level in terms of things that are common to JavaScript regardless of platform, and then look specifically at some Node.js APIs and modules, and finally look at some tools that I'm using to automate a lot of these checks, or at least to highlight parts of code that need more attention when I'm going through a giant code base that's however many thousands of lines. I'm going to try to avoid covering general web application vulnerabilities, so I'm not going to look at like OWASP top 10. I'm looking at quirks in Node.js and JavaScript, things that I wouldn't have expected to be there. And just a note on the word troublesome, or the adjective troublesome here, I'm not using troublesome to mean any of these are inherently bad, more that they're often misused or they're often just incorrectly used, and so if you see them in code that you're looking at, they're worth a second look. So just out of curiosity, how many people here have written or assessed a Node.js app before? Okay, so we've got a small number, but pretty good. So let's start with troublesome JavaScript features. My personal training in computer engineering was largely focused on C and Java, and a lot of the apps that I've looked at are written by developers who were originally hired to do C and Java, and then they kind of got thrown into JavaScript. And so the first surprise that I encountered was the fact that JavaScript actually has more scopes than C and Java. And I'm a bit embarrassed to admit that it took me several months of looking at JavaScript code before I actually pulled out a book and read this. So there are 3 scopes in JavaScript, not 2. So in addition to the usual like local scope or block scope and global scope, you've also got a function scope. And up until ECMAScript 6, almost all code was written in using function scope because the var keyword was the default that everyone used. And so in the var keyword, so the immediate curly brackets around your variable are not what actually scopes it, but it's the entire function declaration. So I've got a beautifully convoluted example up here. If you run code very similar to this in C or Java, you would expect that the final line at the bottom, console.log, admin has password, would print out with the password secret because you've got a shadowed variable there. In JavaScript, this is not the case because they're both at function scope. Both instances of var password are pointing to the exact same spot on the stack. And so your final line is actually going to print out with admin has password 789. Now, you're probably going to tell me, Vince, why would you come up with a convoluted example like that? You're never going to encounter that in production. And that is what I originally thought. But then I came across a blog post from a few years ago. A startup called Meloncard apparently ruined their launch because they forgot a var keyword in a variable declaration. So what they ended up with was a variable that was meant to be function scoped, that was accidentally global scope. They did not run into this, it didn't come up while they were testing. It came up when they launched their web app because they suddenly had, 50 to 100 users accessing their site at the same time, and you saw user requests getting mixed up. So the request object from one user would accidentally get transposed to some other user's request, and so they would not get back the data they expected. So stuff like this actually does come up in production. And so when I'm reviewing code, generally I encourage developers to only use the let keyword everywhere because let actually uses the more traditional block scope. But if I'm seeing things with var or missing a keyword which makes a variable global in JavaScript, then it's worth a second look. Coming again from a C and Java background, JavaScript is weakly typed. There are usually no explicit variable types that are declared in JavaScript, and you've got implicit type conversions that are just messy and counterintuitive. So the double equals sign or the double equals operator actually does silent type conversions for you, and you end up with delightfully awkward behavior like what I've got quoted there on the screen. What I'm comparing, just in case the parentheses aren't coming out properly, is an empty array to an empty object. And so in the first line, you see the empty array and the empty object are not equal to each other. And that's reflected in the second line when I change the operator to a not equals. In the third line, where I take the negation of the empty object, you still get a consistent result. But then if you negate the empty array, then you get the opposite result. So weird stuff like that pops up. If you've looked around at JavaScript documentation online or people whining about JavaScript online, which I tend to do too, to be honest, this is a table that often comes up. This is an equality chart for JavaScript. And what you've got on the left-hand side is what is considered equal when you're using a double equals with implicit conversions. What you've got on the right-hand side is what is considered equal when you're using the triple equals operator, which validates that both the type and the actual value of a variable are equal, not just what the value can be interpreted as. And so, again, going back to like my perspective, like what I'm doing when I'm doing code reviews, I will try to flag or at least look at anything with a double equals suspiciously because there might be implicit conversions happening that might work counterintuitively that might, express as a vulnerability of some sort. Type conversions come up in other places as well. We're not just talking about awkward comparisons, but also just in terms of like how input is handled and how APIs work. So the code I've got up here is just a really naive test for what could be considered SQL injection, which is we're just looking for a single quote anywhere in the input. In the first two, you've just got a string being passed to this test. And so they kind of react the way you'd expect. The second line gets flagged as potential SQL injection because there's a quote there. In the third line, though, instead of just passing in a string, I'm passing in a basic object that just has a string and a field, and that does not actually get tested properly. And again, because JavaScript is weakly typed, you don't get any errors thrown when this happens. You just get false that comes out as a result. And I have seen code where further down the line, that JavaScript object gets converted to a string, and then that SQL injection suddenly works. So I found when reviewing code, it's important to not make any assumptions about the types of user input. Whereas if you're writing, a web application in Spring or in, say, one of the Java frameworks, you might have a lot more assurances. In JavaScript, you don't have those same assurances. How many people here have heard of RDOS attacks? Okay, not very many. RDOS is the buffer overflow of JavaScript. It comes up about as frequently as buffer overflows did when I was doing code reviews in C. So what a RDOS attack comes down to is a regular expression that is vulnerable to easy DOSing. And so there are two necessary factors for this. First off, the regex itself has to be vulnerable, and then the regex has to be sent some sort of bad input. And so the example I've got here up on the screen is a vulnerable regular expression and a variety of bad inputs where I'm just adding a letter A each time. And you'll note that the execution time of each line actually goes up. It doubles with each line. So by the fourth line there, that takes 30 seconds to run on my laptop. Ordinarily, and if you're coming at this from, again, the more traditional web application stack perspective, you would think this is not really an attack, right? It's going to slow down one user's request, and that is the request of the user who's sending the bad data themselves. In Node.js land, though, Node.js works with a single-threaded event loop that is handling all your incoming web requests. So when that last regex gets evaluated, that takes 30 seconds of server time. That actually blocks all request handling for that server. So again, add another 2 A's, and you've got a request that will DOS a server if you send it every 2 minutes. So it is worth, when you're reviewing Node.js code, look at the regular expressions that are in it, not just from the perspective of are they actually validating the data you expect them to validate, but are they susceptible to this sort of RDOS attack. There's an NPM module called SafeRegex that will actually run some heuristics and will let you know if the regular expressions you're looking at are vulnerable or not to RDOS. Move on to remote code exec. Everyone, I'm assuming, has probably heard eval is evil or some sort of catchphrase like that. JavaScript has a delightful eval function, that's line 1 there, which takes a string and runs it as JavaScript code. And obviously, if you're going to pass user input into that, then you've got yourself a one-line remote code exec. In Node.js, there are actually 9 such APIs. Eval is not the only one. So if you're just grepping for eval, you're probably missing most of the potential exploits. So that's everything from eval itself, which still does exist in Node.js, to the new function constructor, can take a string and actually return, like you can run it as code. The VM module, which is a core Node.js module, which is useful in other contexts, can also, again, create executable code from a string. So I find it's useful to look at any usage of any of these 9 APIs. One piece of advice I found shared online is to often look for set timeout and set interval, which are similar in that they, at least in browsers, will take a string and will run that string as code. In Node.js, though, these 2 APIs do not take strings. They require a function, so they're actually not a vector for RCE, at least not in this way. And finally, in terms of troublesome JavaScript features, let's look at objects and arrays and the weird APIs. So JavaScript has some weird APIs that let you change very fundamental properties of any object or array that you're working with. I've listed the 5 weirdest ones, in my opinion, up there. I guess this is, if you want a really in-depth look at this, there's a talk I'd recommend by Natalie Silvanovich from The Last Black Hat, where she just rips apart JavaScript interpreters using these APIs. But I've got a really simple example here where if you call object.defineProperty on an array, you can actually replace the get method for a single element in that array. And so what I'm doing here with this stupid example is just replacing the getter for foo sub 0 so that it increments another entry in that array and returns that. So every time you access foo sub 0, it'll just give you an incrementing integer. I don't know if there's a legitimate use for these APIs or not, but in general, if I'm seeing developers using these APIs, then it's definitely worth a second look to figure out what are they actually doing with them. And again, just to reconsider how you're doing your overall code assessment or code review, because you're changing fundamental properties that you would assume, that accessing an element in an array wouldn't change it. If there's a call anywhere in your code to object.defineProperty, you need to revisit that assumption of how that code works. So let's move on to actual Node.js APIs, both in the core Node.js build and in the bunch of modules that ship with it that tend to be troublesome. I'll start with the crypto module in Node.js. So crypto, in most cases, is actually just wrapping OpenSSL. There are 2, I would say, dangerous, documented but not very well documented weaknesses, and that's crypto.createCipher and crypto.createDecipher, which take an algorithm and a password and basically give you back a cipher function using the algorithm you asked for, and they do a key derivation under the hood using the password you provide. Unfortunately, the key derivation is done using MD5 with 1 iteration and no salt, and there is no way to override that. So I don't know why these functions aren't deprecated. The documentation is pretty clear that you should not be using them. I have encountered them in production code before, so if you see those pop up, they're probably wrong. Let's move on to the DNS API. So there's a DNS module that is part of core Node.js. It gives you a bunch of functions for resolving host names to IP addresses or doing reverse lookups. They're not exactly intuitive, or they're weirdnesses to how they're implemented. So for example, there's both a DNS.lookup and a DNS.resolve API, which look very similar. And if you call them, most of the time you'll get the same result back. Under the hood, though, they're implemented completely differently. So DNS.lookup is actually using your operating system APIs to do its lookup, whereas DNS.resolve is directly doing a DNS query. So if you're operating in an environment, where your server is behind a firewall, you might have weird entries in your etc hosts to redirect things through reverse proxies or what have you. Or you might have a weird configuration in one of your resolve.conf files. The DNS.lookup API or the call to DNS.lookup will reflect that. The call to DNS.resolve will not reflect that. And so one of the things I look for when I'm assessing applications is to see that they're consistently using one family of APIs, not both. I'm sure there is some sort of weird, subtle vulnerability there if you end up with a host name that suddenly changes IP address halfway through your app execution. JavaScript is a higher level language by the common definition of higher level, right? So you'd expect you are not dealing with things like buffer overflows anymore, and you'd think you're not dealing with things like uninitialized memory leaks anymore, but it turns out you are. So this came out a couple of years ago, and it did the rounds on like the NetSec subreddit and on Hacker News, that the buffer API that Node.js gives you actually returns uninitialized memory by default. So the buffer constructor, there are two buffer constructors I have listed there. Under the hood, there's actually a lot more than two. It depends on the type of the variable x that you're sending in. But if x is an integer, it gives you back an empty buffer, but empty does not mean zeroed. It's just whatever was in that memory that previously. So both those constructors have been deprecated. Though they still exist, their behavior depends on the version of Node.js and what command line flags you're sending to Node.js. So sometimes you might get uninitialized memory, sometimes you'll get memory that is zeroed out properly. So they've been replaced by a bunch of alloc constructors. But it's worth noting there are still two alloc constructors, which are called alloc unsafe and alloc unsafe slow, handily enough. Unsafe in this case refers to the fact those constructors definitely give you uninitialized memory. And so if you ever see those being called in code, it's worth double checking that that memory is being zeroed out or being completely copied over before it's returned to a user. So V8 is another core Node.js module. I guess more importantly, V8 is the underlying JavaScript engine that Node.js runs. It is the same JavaScript engine that Chrome runs. It's supported, I think it's implemented and supported by Google. So Node.js Node.js gives you a V8 module that lets you access underlying properties of your JavaScript interpreter. Most of the APIs it gives you access to are pretty harmless, things like just getting access to your stack size, your heap statistics and whatnot. However, there's a v8.setFlags from string that is troublesome. It's, again, one of those APIs I wonder if there's ever legitimate use for this in production code. Its own documentation says that calling v8.setFlags from a string may result in unpredictable behavior, including crashes and data loss, or it may simply do nothing. And so this lets you change the flags that V8 is currently running with. And again, because most of this is fine-tuning performance, so most of the flags that you can change are things like optimizations, enabling, disabling what optimizations V8 is running with, or what debug support it has at the moment. There are some definite dangers looking at, like actual dangerous flags you can call, though. So use strict can enable or disable strict mode globally in your V8 interpreter, and v8.setFlags from string will let you change that. There's an allow unsafe function constructor, which to this day I have not found out what that does, but it has unsafe right there in the name. So in general, though, again, one of the things I grep for, if devs are calling set flags from string in their code, what is the reason for it? It's worth double checking. And I'll go through a few other modules very briefly. Process is another core Node.js module, which, again, is something that has very legitimate uses. It also can be easily misused. It gives you access to APIs to change the UID or the GID that the node process itself is currently running with. Now, obviously, this is still restricted by underlying OS permissions, so you won't be able to change UID to anyone. But if these APIs are being called, they're worth a second look. Similarly, it can send signals to other processes. Child process is another core Node.js module that lets you launch other binaries or launch other scripts on your system. Again, there are underlying OS permissions that will restrict what you can or cannot do, but worth a second look if you see this in code. And FFI is just random mention that I encountered, I don't even remember in what code base a few months ago. FFI is a third-party module that stands for foreign function interface that basically simplifies dealing with native libraries. It lets you dynamically load a native library and talk to it without writing a line of C code. So every single vulnerability that you dealt with in C can suddenly happen in JavaScript if this is misused. So if you see FFI being used, it's worth additional review. Now, I've just given you a really long list of functions to look for, and rather than just grep for all of them, there are easier ways of dealing with this. And so I'm just going to go through a few of the tools that I use to make my life easier in dealing with what I just listed there. ESLint is a tool that I swear by. It is a linter that's based on Esprima. Esprima is also fun if you get a chance to work with it. It's a lexer parser that's really easy to extend and write some rudimentary static analysis with. But I'd recommend ESLint in two contexts. I found it is useful to both have a set of rules that I try to convince developers to use or that we try to promote internally, and to have a separate set of rules that I use when I'm doing vulnerability assessments and when I'm doing code review that just highlight risky areas of code for me. So just going through a few quick sample rules. So the no var rule basically raises a warning whenever you declare a variable using the var keyword or no keyword, which means it's either globally scoped or function scoped, which are the two problematic scopes. The strict rule just enforces strict mode, so if there's ever a script that doesn't have a use strict at the top, it'll flag that for you. The semi rule warns you whenever you're relying on a very obscure JavaScript feature called automatic semicolon insertion, which I've never encountered in production. I've seen textbook examples of how this can go wrong, but they're very convoluted examples. It's worth having as a rule, though, just for like clean code. And then from an assessment perspective, I've got my own rule set that I run before I review code that just highlights things. No eval is one example. I'll just highlight anywhere where eval is either implicitly or explicitly being called in the code. The triple EQ rule highlights anywhere where you've got a double equals being used instead of a triple equals. Block scoped var is a really useful rule in that it highlights when you have, so ultimately you're going to get code where, you know, best practices or whatever you've recommended has been ignored. So I often get, you know, a chunk of code where var is the only keyword used to declare a variable through like thousands of times. So highlighting where var is used is not useful because I'm not going to go through thousands of variable declarations. On the other hand, block scoped var is neat because it highlights where a function scoped variable is used outside of the current block, which is exactly the sort of behavior you'd expect, or, you know, exactly the sort of thing that would indicate an error if you know that code is being written by, say, someone who doesn't expect function scope to be a thing. And so moving on from those rules, ESLint is also great because you can write rules for it that interface directly with the Sprema. So in a few lines of code, if ESLint doesn't support something, you can probably have your own rule for it and do really basic static analysis through that. So I've included two sample rules here. ESLint has a built-in rule for blacklisting modules. It has no built-in rule for blacklisting functions, so I threw that together. And then in my ESLint configuration file, I've got a list of functions that are blacklisted that I got warned on. And so this just tests the function based on the function name directly or the module dot the function name. And moving up in complexity a bit, going back to those DNS APIs, in fact, there are two families of DNS APIs. This is a rule I've written that would just logs what DNS family you're using the first time you call into a DNS API. So if you're using lookup, it'll log that. And then if it ever sees an API from the other family being used, it'll warn on those lines. So that's proven useful in the past. And one final topic to look at is dependencies. So it took me about a year of assessing Node.js code before I decided to try writing Node.js code. And when I wrote it, I wrote a really basic web app that just had like 2 post endpoints. I wrote to SQLite database, and that was the dependency tree I ended up with. That is over 250 modules worth. NPM, which is the Node package manager, encourages people to submit like one-line modules and to reuse code almost to a fault. So you often end up with insane dependency trees like this. And when I'm doing generally a white box assessment, I do not have time to go through third-party code. Even if I did have time, like assessing this would probably take, you know, the better part of several months. So there are some really great tools and really great vulnerability feeds that I often refer to. The two in particular I like to list are the Node Security Project and Snyk.io. So they both publish vulnerability feeds for NPM packages, and they both have command line tools that will just scan your dependency tree quickly and tell you if there are any known vulnerabilities against any packages that you are currently depending on. Snyk.io has a neat feature I haven't really played with enough yet that actually lets you handle indirect patching if there is a vulnerability found that isn't easy to address. And yeah, that's about it. So to recap, I just going through that long list, there are a lot of language-specific things to look for in Node.js. They're worth keeping in mind if ever you're assessing or writing an application, and it is not just like C or Java. And I highly recommend playing with and extending ESLint and relying on vulnerability scanners for those sorts of third-party vulnerabilities. Thank you. I don't know if we have time for questions. I can take a couple of questions if there are any. Yeah. I do not because of legal, but I will post the slides so you can copy paste the code out of there.